So today I featured an old song called The Girl from Yesterday from Eagles. Why does the lyrics address a girl from yesterday? Actually, the same girl from yesterday who has become different because of something. Meaning that today we will talk about something the same or different. What you can select, you can adopt different methods based on your own understanding or philosophy. Today we will talk about the gear assemblies and indeterminate torsional elements. So the objectives are listed here. So first we will learn how to calculate the angles of twist in gear assemblies. We already talked about how to calculate the angle of twist in torsional shafts combinations. So today you will see that this will be a little bit different because you will involve the gear assemblies. Then you will use the 5 rules to think about how to calculate the twist in gear assemblies. Then we will solve indeterminate problems in torsional elements. Please recall that in last chapter we already learned how to solve indeterminate problems in axially loaded elements. Right, so now you will see, in this class you will see that this will be something the same or different, or a little bit different. Rather in indeterminate problems, you will see that you will be able to use a free body diagram to build equilibrium equations. Then you will figure out that the number of unknowns will be more than the number of equations you can build. That means you need to write additional equations like based on compatibility to solve these problems. But in the previous chapter, when we have the axially loaded elements, these additional equations can be written as like a delta 1 equals delta 2, or delta 1 plus delta 2 equals 0. Right, so today you will see that actually the same or at least similar. So you can build the additional equations by writing phi 1 equals phi 2, or phi 1 plus phi 2 equals 0. So before we start the contents, as a routine, we will have a review. So last time, we talked about 5 rules, right? The 5 rules in gear assemblies. And we defined an important number called gear ratio. So then please look at these two gear assemblies shown here. The first one and the second one. Please examine these 2 gear assemblies and answer a question: Are these gear assemblies realistic or not? Look at the first one. Is this a realistic gear assembly based on our 5 rules? No, this is not realistic, right? Please look at the yellow one, the yellow gear, and the gray one, the light gray one. According to our rules, well, if you have a larger gear, as shown by this yellow one, and the light gray gear connected directly to each other, so if the larger one is turning, while the gray one, the smaller one, its angular velocity should be higher than the larger one, right? So that is one of our rules, our rule number 3. Right, so this one doesn't obey our rule number 3, so this is not a realistic gear assembly. So you can do your own analysis to other gears in this system. Okay, so the second gear system is somewhat realistic, because at least your smaller gear is turning faster while larger ones are turning slower. Okay, then this, please remember this, we have defined the gear ratio. And what is the gear ratio? Well, we said that when you have two gears directly combined to each other, when you're moving from a smaller one to a larger one or moving from a larger one to a smaller one, so you can always define the gear ratio as dB over dA. When you're moving from A to B, you can define the gear ratio as dB over dA, or RB over RA, or NB over NA. Right here, D is the diameter of the gear, R is the radius, while N is the number of teeth of the gears. And then please recall, we have 5 rules. Right, for those 5 rules, the first one describes the overall power. Right, we define power as torque by angular velocity. Right, the rule number 1 says the power always keep constant in this gear system. When you're moving from one gear to another gear, while the torque may be changed, while the angular velocity may be changed, but the power always keep constant. So rules number 2 and number 3 describes the moving from one gear to another gear while these two gears are directly connected to each other. While the rule number 2 says when you are moving from a smaller gear to a larger gear, then the torque will be increased. While according to number 3, when you're moving from a smaller gear to a larger gear, your angular velocity will be decreased, and the angle of twist will also be decreased. Well, those are these rules number 2 and number 3. Then rules number 4 and number 5 are for two gears connected through a shaft. Right, if these two gears are connected with a shaft, then they always have the same torque as well as the same angular velocity. Okay, those are those 5 rules. Then in this section number 4.4, we will analyze the angle of a twist in gear assemblies. Of course, we will use gear ratio and those 5 rules to do this analysis. Okay, in this slide, please look at these 2 gear connections. But it's in this case 1 and case 2, in both cases, we just have 2 gears, gear A and gear B. Just in case 1, gear A and gear B are connected with each other through a shaft, while in the in the case 2, where this gear A and gear B are directly connected. Now if we define the angle of twist of A as phi A, angle of twist of B as phi B, so let's examine the correlation, the relationship between these 2 numbers, phi A and phi B. Okay, let's look at the first connection as shown here. So what do you think is the correlation between phi A and phi B in case number 1? Does rule number 4 apply? Rule number 4 says that when you have 2 gears connected through a shaft, they should always have the same angular velocity, but not the same angle of a twist. So you cannot write phi A equals phi B. This is wrong. Well, the correlation between phi A and phi B should be written as phi B equals phi A plus phi 1. Well, here, this phi 1 is the angle of twist in shaft number 1 connecting these two gears, and it can be calculated by TL over GJ. This equation had been given last time. So how about the second one, the case number 2? If you look at the case 2, this phi A and phi B are directly connected to each other. So now can we use rule number 3? So the answer of this time is yes, right? Since they are just directly connected. So we say that when the diameter increases, when it's moving between two gears, when you have a larger diameter, the angle of twist will be increased, or will be decreased. So here we can correlate these two, phi A and phi B, through this equation. Like phi B equals negative gear ratio by phi A, or phi A equals negative gear ratio by phi B. Right, these are the two equations we can use to correlate these two numbers. However, in which case we're using gear ratio AB, and in which case we should use gear ratio BA. This is always confusing. I think this is the most confusing part of our last lecture. In last class, we defined the gear ratio AB. That is the gear ratio when you're moving from gear A to gear B. For sure, in this case, this number should be smaller than 1. Then the gear ratio BA is the gear ratio when you're moving from B to A, where in this case, this should be a number larger than 1. But here's the question, so which one should we use in these two equations? Although I have to give clear definitions to gear ratio AB or gear ratio BA, I think it's always confusing. So to simplify this case, please just ignore these equations and ignore the definitions of gear ratio. Just keep in mind that they can be calculated. These gear ratios can be calculated by diameter ratios or number of teeth ratios. Right, so one of them is larger than 1, while another is smaller than 1. Right? So please ignore these details. Just keep in mind the nature of rules number 2 and the rules number 3. Well, these rules say that when two gears are directly connected, the larger one always has larger torque but smaller angular velocity and smaller angle of twist, while the smaller one always has smaller torque and larger angular velocity or angle of twist. And always use this criteria to examine your results of calculation. Okay, so here just let's compare these two gears. The gear A is larger, gear B is smaller. So gear A should always have a smaller angle of twist. So in the first equation, when we ask the relation between phi B and phi A, and use this equation to describe their relation, do you think the gear ratio is larger than 1 or smaller than 1? It should be larger than 1. Then how about in the second equation? The gear ratio, phi A equals negative gear ratio by phi B. So the phi A should be smaller, so the gear ratio should be smaller than 1, right? By the way, you can see that I have framed this paragraph, these right words, using a golden frame with a golden color, meaning that this is golden rule. Please always keep this in mind and use it to examine your calculation results. Well, in this way, you can avoid mistakes. Now let's look at the two systems. And the first system is just a directly connected shafts. We already analyzed this before. And the case 2 is the shafts connected by gears. So now let's determine the angle of twist at point D when we add a TD, a torque, at this end D. Then let's analyze the difference between these two systems. In the first system, case 1, of course, the first step number 1 is determine the angle of twist in each shaft. I think so far you should already know how to use free body diagram to determine the internal torque in shaft number 1 and shaft number 2. Well, obviously in this case, when you add a torque D in the end of D, at the end of D, so the internal torque in 2 and 1 will both be TD, right? Just no matter what is the result. So if you can calculate, you can determine the internal torque in shaft 1 and shaft 2. So the phi 1, the angle of twist in shaft 1 can be calculated by T1L1 over G1J1. And the phi 2 can be calculated as T2L2 over G2J2. Then how about in the second step? Determine the angle of twist at the end D. So this will be simple. The phi D equals phi 1 plus phi 2. So now let's look at case 2. When these shafts are connected by gears, then step 1, again, you just need to use free body diagram to determine the internal torques. Well, if you can determine that, then the phi 1 can be calculated as T1L1 over G1J1 and phi 2 by T2L2 over G2J2. Then how about step number 2? Can you still determine the angle of twist at end D by phi D equals phi 1 plus phi 2? No, this time you cannot do that because point C and point B and point C are connected by gears. So to determine the angle of twist at end D, so first of all we need to determine phi B. Well, you can see that the B, gear B and the fixed end A had been connected by shaft 1. So this phi B equals phi A plus phi 1. Right, since the point A had been fixed, so phi A equals 0, so phi B equals phi 1. Then let's look at the gear assembly B and C. Well, after the transmission, the phi C can be calculated from phi B and the gear ratio. Right, so this equals negative gear ratio by phi B. But here you need to think about, is this gear ratio larger than 1 or smaller than 1? Obviously, C is smaller than B. Right, so the phi C is smaller than now the diameter of gear C is smaller than the diameter of gear B. So this angular velocity and angle of twist should both be larger than B. So this gear ratio here should be larger than 1. You can determine this gear ratio by the diameter of B over diameter of C, or the number of teeth of B over number of teeth of C. Then this phi D can be calculated from phi C and the angle of twist of shaft 2. Right, this is phi C plus phi 2. Then when we combine the three equations, you can get the phi D equals phi 2 minus gear ratio by phi 1. So this is the equation which you can use to determine the angle of twist at point D if C and B are connected by gears. Okay, here by I click on this blue words, you can see a version B.
The topic that I want to talk about is...
Okay, here is another video provided by Nick Libri, so you can also watch this video. Maybe you can find more details. And this in the second half, this video includes a example, like how to use these principles that we just explained to solve some problem. Okay, then we will give 2 more examples to explain to learn how to use this principle to solve practical problems. Okay, this is the end of this video, but not the end of this class. Please use your PowerPoint to go through the later slides.